These are some examples of fundamentals algebraic operation of matrices. Let's start with the addition of matrices. Let's A and B are two different matrices. If A and B be two matrices of the same order, then their sum A and B is defined as the matrix, each element of which is sum of the corresponding elements of A and B. So if A has the elements of Aij's and B has elements of Bij's, then A plus B is equals to the sum of their respective or corresponding elements. So let us solve this A and B matrices. Okay, so the corresponding element is 4 and 1 and 2 and 0, 5 and 2, then 1 and 3, 3 and 1, negative 6 and 4. So therefore, the sum of their elements are 4 plus 1 and 2 plus 0, 5 plus 2, then 1 plus 3 and 3 plus 1, negative 6 plus 4. Then A plus B is equals 5, here is 4, 2, 4, 7 and negative 2. So that is the answer. Study properties of addition of matrix. So it is has commutative law and associative law. Then the subtraction has also the same properties. So the operation is the same. We must recognize the same element. So 8 minus 3 and 6 minus 5, 4 minus 1, 1 minus 7, 2 minus 6 and 0 minus 2. Therefore, A minus B is equals 8 minus 3, then 6 minus 5, then 4 minus 1. Here is 1 minus 7 and 2 minus 6, 0 minus 2. So therefore, A minus B has the elements of, this is 5, this is negative 6, this is 1, negative 4, 4 minus 1 is 3, this is negative 0. Okay, that is the answer. So some kind of matrices are symmetric matrix and skew symmetric matrix. So in symmetric matrix, a square matrix will be called symmetric if for all values of I and j, when Aij is equivalent to Iji. So that's the reciprocal. So here, this one is A 1, 2, row 1, column 2, and this one is A row 2, column 1. So if that is equals, that is called symmetric matrix. So this position here is A row 1, column 3, and here is A row 3, column 1. the same with the F and F here. Then the skew matrix is called skew when Aij is equals to negative Aj. So the corresponding or the reciprocal of row and column is negative, like the illustration here. Okay, let us write the matrix of A given below as the sum of a symmetric and a skew symmetric matrix. So the original matrix is this one. So let us transpose the original symmetrics or the original matrix. So the row will become column. So like it here, this row will be column 1 and second row will be column 2 and third row will be column 3. Then let us add their elements. So A plus A transpose is equals, so addition 1 plus 1 and 2 minus 2, 4 minus 1, negative 2 plus 2, 5 minus 5, then 3 plus 6, negative 1 plus 4, 6 plus 3, and 3 plus 3 equals this is 2, this is 0, this is 3. This is 0, 0, this is 9, this is 3, this is 9, and this is 6. So that is the symmetric matrix because of we just create this pattern. Okay, so let us subtract the original matrix and the transpose of matrix. So 1 minus 1, 1 minus 1, then 2 minus minus 2, that is positive 2, then 4 minus minus 1, positive 1, then negative 2 minus 2, 5 minus 5, and 3 minus 6, negative 1 minus 4, 6 minus 3, and 3 minus 3. So the difference, this is 0, this is 4, this is 5, this is negative 4, 0, this is negative 3, this is negative 5, this is 3, this is 0. Okay, that is skew matrix. One positive, one negative, negative, then positive, negative. Okay, let us add their elements. If we add their elements, so this is 2a, 2a. Then this is positive, this is negative, 0. Then 2a is equals their elements. Rewrite 2, 0, 3, 0, 0, 9, 3, 9, 6, plus 0, 4, 5, negative 4, 0, negative 3, negative 5, 3, 0. Then divide both sides to 2. Therefore, the element is 2 over 2, that is 1, 0, 3 over 2, this is 0, 0, this is 9 over 2, this is 3 over 2, 9 over 2, this is 3, plus 0, this is 2, 5 over 2, this is negative 2, 0, negative 3 over 2, negative 5 over 2, and 3 over 2, this is 0. So that is the answer. So if you try to add that symmetric and skew, will give you the original. It will give you the original, this answer. Okay, if you get the sum of it, it will give you back to this result. Okay, let us solve the triangular matrix. A square matrix of all of whose elements below the leading diagonal are 0 is called an upper triangular matrix, and a square matrix of all whose elements above the leading diagonal are 0 is called the lower triangular matrix. So these are two types. So this is called upper triangular because below the major diagonal has 0, 0 entries, and here above the major diagonal has 0, 0 entries. That's why it's lower triangular and this one is upper triangular. So for the next example, express matrix A as the sum of the lower triangular matrix and upper triangular matrix. Okay, in order to arrive in these forms of upper triangular and lower triangular, we have to equate the original or the given matrix to, let's say, this form is the lower triangular and this form will be our upper triangular, representing the variable of A, B, C, D, E, F for lower. Then you have to create the diagonal of the other matrix to 1, 1, 1 so that the equation will be solved easily later on. So doing the addition of lower and upper, so we have here A plus 1 and 0 plus P, then 0 plus Q, B plus 0, C plus 1, 0 plus R, D plus 0. Then all these elements will be equate to this element will be equate to 1, and this one to -2, this to -3, this to 3, and this element to 0, this element to 5, and so on. And f plus 1 will be equated to 1, and the result, okay, the result are here. The final is a equals to 0, b is equals to 3, d is 5, and so forth. Then replace our variables to their respective result values. The lower matrix now has the values of 0, 0, and 0, and 4, b, this is 3, and c is -1, then 0, letter d is 5, and letter e is 6, then f is 0. And for upper triangular matrix, so the diagonal is originally 1, then we have p equals to -2 and q to -3, then r 5, and these are the answer. So for the scalar quantity, when you say we have to multiply matrix A to 3, 3A will be, it become 6, this is 9, and this is 12, this is 12, and this is 15, this is 18, this is 18, this is 21, and this is 28. So this is the answer. So this is algebraic operation. So find the value of x and y, z, and small letter a. So again, equate the elements. X plus 3 will be 0, therefore from here x is equals -3, and z minus 1 is equals 3, therefore z is equals 4. Then y plus x is equals -7. Then we have value of x, then 2y plus value of x is -3 equals -7. Then y is equals 4, -4 over 2, that is -2. Then 4a minus 6 is equals 2a. Then 4a minus 2a is equals 6. Then 2a is equals 6. Then a is equals 3. So that's the answer. X is equals 3 equals -3, and y is equals -2. Then z is equals 4, and a is equals 3. So that is the answers.